Hello everybody, how are you? You are doing very well. Today inshallah we will continue our lesson about solubility, equilibrium. In our previous lesson we defined what is the meaning of solubility product constants, KSP, and how to calculate the value of KSP. Okay, so today we will learn inshallah how to calculate solubilities using solubility product constant KSP. Okay, so you may remember that we said solubility product constant KSP of a substance is the product of the molar concentrations of its ion in a saturated solution, each raised to the power that is the coefficient of that ion in the balanced chemical equation. And we learned how to write the solubility equilibrium expression, and we say that KSP is equal to what again? Concentration of the product raised to the power equal to the coefficient of these ions. Okay, and we said that writing a balanced chemical equation is very important before we start our calculation. Okay, so today inshallah we will understand what do we mean by solubility and how can we calculate solubility if KSP is given the problem, or how to calculate KSP knowing the value of solubility of such a solid. Okay, so guys, solubility of a solid is an equilibrium position that represents the amount of the solid required to form a saturated solution with a specific amount of solvent. So solubility has an infinite number of possible values at a given temperature and is dependent on other conditions like presence of a common ion. While if you remember, for the solubility product they say that it has only one value for a given solid at a given temperature. So guys, here we have our first sample problem. Sample problem being, says calculate the solubility product constant KSP for copper chloride, given that the solubility of this compound at 25 degrees Celsius is 1.08 times 10 to the negative 2 grams per 100 grams of water. So guys, let us analyze our question. The given value is the solubility of copper chloride, and known is the KSP. And guys, solution here in the first step we need to convert the units of this value into mole per liter. How? By following this plan, guys. Okay, so we need first of all to convert the grams of the solid or of the copper chloride to what? 2 moles, and we need to convert the amount of water here in grams into liter. Okay, so now it will be as the following plan. We will start by converting what? By converting the amount of or the grams of water. Grams of copper chloride over 100 grams of water will be multiplied by the conversion factor. Okay, the conversion factor here we need to convert the grams of water first into milliliters, and then we'll convert the milliliters into milliliters. Okay, so now we will multiply this by the conversion factor, which is 1 gram of water over 1 ml of water multiplied by 1000 ml over 1 liter. So we need to use these two conversion factors in order to convert the amount of water in grams into milliliter. Okay, so for the last conversion factor, guys, we are using this conversion factor in order to convert the amount of this solid in grams into moles. Okay, so here guys, we will multiply this ratio by what? 1 mole of copper chloride or copper chloride over grams of copper chloride. So guys, actually usually in order to convert the grams into moles, we need to divide the grams that we have. We divide it by what? By the molar mass of this compound. So we'll find out the molar mass of this compound from the periodic table, and we can just divide the grams by the molar mass that you will calculate from the periodic table. Okay, so you can do these steps like separately. Just you can convert the grams of the solid alone into moles, and convert the grams of water into a liter alone, and then combine them together, or you can just follow these plans and convert everything together. Okay, so guys, now as I said, we need to write the balanced equation that represents the dissociation of the solubility of the copper chloride. To be as following: 1 mole of copper chloride will yield 1 mole of copper and ion, and 1 mole of chloride ion. Okay, so Ksp, as we said, is equal to the concentration of the product raised to the power equal to the coefficient of each of these ions. So it will be as following. Okay, and as we know, at equilibrium, guys, the solubility of copper chloride should be equal to the concentration of each of these ions. So the concentration of copper is equal to the concentration of chloride, and is equal to the solubility in mole per liter. So here, all what we need is to, in order to calculate Ksp, we need to find out the concentration of these ions. From where we will get the concentration of these ions, guys? By knowing the solubility of this compound. But we actually know the solubility, but we have it in different atoms, so on different units. So we just need to make the conversion process and convert these units into mole per liter, and then the value that we will get will be equal to the concentration of each of these ions, and after that we can just substitute the values in this formula and calculate Ksp. So guys, now we'll substitute the values that we have. As we said, we have 1.08 times 10 to negative 2 grams of copper chloride, and this value should be converted into what? Into moles. How? As we said, we will divide it by the molar mass of this compound from the periodic table, and the molar mass will be equal to 99. Okay, what about, guys, the conversion of the amount of water? We need to convert it from grams to liters. So guys, we need to multiply it by 2 conversion factor. The first conversion factor is to convert grams to milliliters, and then we'll convert the milliliters into liters. Okay, so guys, just follow this plan whenever you have such a question. Okay, so at the end, guys, the final value will be 1.09 times 10 negative 3 mole per liter. This is the solubility of the copper chloride in mole per liter. So all this step is just to convert the units from grams of copper chloride per grams of water into moles of copper chloride to liter of water. Okay, so once we get the solubility in moles per liter, we can easily find out Ksp value. As we said, at equilibrium, concentration of the ions will be equal to solubility of the solid. So the concentration of both the chloride ion and the copper will be equal to 1.09 times 10 to negative 3. And now, since we have the concentration of copper and chloride, we can find out Ksp. So Ksp is equal to what? Concentration of copper raised to its coefficient, which is according to the balanced equation, coefficient is 1 for both copper and chloride. Okay, so concentration of, it will be concentration of copper multiplied by concentration of chloride, since the coefficient is equal to 0, and the final answer will be 1.19 times 10 and negative 6. Okay, so now guys, we will learn how to calculate solubility by knowing the value of KSP. So the solubility product constant can be used to determine the solubility of a sparingly soluble salt, and sparingly soluble salt is kind of salt that has a limited solubility. So guys, suppose we have this question: how many moles of barium carbonate can be dissolved in 1 liter of water at 25 degrees Celsius? So here we need to find out the solubility of barium carbonate. How? By knowing KSP value. So from the table, KSP for barium carbonate is equal to what? Is equal to 5.1 times 10 to negative 9. Okay, and as we know, this is the formula of KSP, and here we have the balancing equation for the dissociation of the barium carbonate. Okay, so 1 mole of barium carbonate will give us 1 mole of barium cation and 1 mole of the carbonate anion. The KSP will be equal to concentration of barium multiplied by concentration of carbonate, which is equal to 5.1 times 10 negative 9, and this value you will get it from the table, or you will have this value given in the problem. So now we know the value of KSP, and by knowing the value of KSP, we need to find out the solubility of barium carbonate. Okay, so guys, as I said, at equilibrium, solubility, which is the unknown, and we will represent the solubility here by X. So X, which is solubility, equal to concentration of carbonate ion, and at the same time is equal to the concentration of barium ion. Okay, and now guys, KSP is equal to what? Concentration of barium ion multiplied by concentration of carbonate ion. Both of them are unknown, so we will represent these ions by X. So KSP will be equal to X squared, which is equal to 5.1 times 10 to negative 9. So X squared equal to 5.1 times 10 to negative 9. Now by taking the root of this value, X will be equal to 7.1 times 10 to negative 5. Okay, so now X, which represent what? Concentration of barium and the concentration of carbonate ions. Okay, so concentration of barium and concentration of carbonate ions is equal to 7.1 times 10 to negative 5, and as we said, at equilibrium, concentration of these ions will be equal to concentration of what? Of the solubility of this solid, and here the solubility of barium carbonate will be equal to 7.1 times 10 to negative 5. Okay, so guys, another example for or to know how to calculate solubility of silver bromide, knowing the value of KSP. Okay, the same way, KSP is equal to 5 times 10 to negative 13, and we need to find our solubility of silver bromide. So silver bromide will dissociate according to the following equation: 1 mole of silver bromide will give us 1 mole of silver and 1 mole of bromide ion. KSP value is equal, as I said, to concentration of silver multiplied to the concentration of the bromide, and at equilibrium we say that solubility, which is here the unknown value, or X, is equal to the concentration of what? Concentration of silver and the concentration of the bromide ion. Okay, both the concentration of silver and concentration of bromide ion are unknown, so we will assume that the concentration of bromide and Aj is equal to X. Okay, so guys, again, KSP is equal to the concentration of silver ion multiplied by bromide, the concentration of the bromide ion. So x multiplied by x equal to x squared. Ksp is equal to x squared, which is equal to 5 times 10 negative 13. We take the root of this value, so we can get x, and knowing x we will know the value of solubility. X, as we said, is the concentration of of the silver and the bromide, and is equal to what? To 7.1 times 10 negative 7. And since the solubility at the equilibrium, the solubility of the solid is equal to the concentration of the ions that will be released from this solid, then the solubility will be equal to 7.1 times 10 to negative 7 mole per liter. So guys, I wish that these examples are clear for you. Thank you, and inshallah later we will practice more question about how to calculate solubility knowing Ksp value, or how to calculate Ksp value knowing solubility value. Okay, so thank you guys, and see you later.